Hello, my name is Sarah Mahmood, and this is my experimental design project on comparing plant growth for arugula seeds using silty and loamy soil. So first for the abstract, two types of soil were experimented during this experimental design project. The first soil is silty soil and the second is loamy soil. I planted 3 arugula seeds in each pot to observe which soil resulted in faster plant growth. I measured the plants every 3 days and watered them every day. The results conclude that silty soil has a faster growth rate, while the loamy soil resulted in faster germination. The data does not support the hypothesis that the loamy soil will have faster plant growth. The plants were planted in my backyard outdoors during the duration of the experiment. The soil that the arugula is planted in can result in the slower or faster growth rate. Now for the introduction. So in this experiment, I tested 2 different types of soil, loamy and silty soil. I planted arugula seeds in pots with the types of soil. I compared the growth rate of each seed for a month in my backyard. The seeds planted in loamy soil germinated faster, but the seeds planted in silty soil had an overall faster growth rate. Agriculture did not suffer from soil compaction using silty soil, but it did using loamy soil. This further supports the conclusion that silty soil is better for agriculture. I hypothesized that the seeds in loamy soil would grow faster than the seeds in silty soil. The main research question is, which soil will make the arugula grow faster? The plant growth was measured every 3 days for consistent data. And now for the methods. I started off this experiment by purchasing 2 pots, arugula seeds and the types of soil needed, which were the loamy and the silty soil. I poured the silty soil into one pot and the loamy soil into another. Both pots had approximately the same amount of soil. After that, I placed 3 seeds in each pot, each seed being 3 inches away from the other. The seeds were planted in my backyard outside in the sun at all times. I watered each pot with 1/8 of a cup of water every day. I measured the growth of the plants every 3 days in centimeters at approximately 3 p.m. I also recorded the weather conditions and temperature as well as observations of the plant growth every 3 days. I continued this pattern for 27 days until I had enough data collected. For the results, the arugula seeds planted in the silty soil grew faster than those planted in the loamy soil. In Figure 1, the arugula in loamy soil started growing faster than the arugula in silty soil. As time went on, the silty soil began to grow at a faster rate until it outgrew the arugula seeds in the loamy soil. In Figure 1, the data shows that the arugula seeds planted in loamy soil began to sprout first, but grew at a slow rate. The arugula seeds in the silty soil did not sprout until after the seeds planted in the loamy soil, but once they did sprout, they had a faster growth rate. At the end of the table, the data shows that the arugula seeds in silty soil grew 3 centimeters more than the arugula seeds in loamy soil. The data in Figure 2 shows exactly when the arugula seeds in silty soil outgrew the arugula seeds in loamy soil. From this bar graph, the data reflects that the plant started off with similar growth rates. Later on in the bar graph, the arugula seeds in the silty soil began to grow faster, therefore silty soil results in faster plant growth for arugula seeds, but loamy soil results in faster germination. Now for the discussion. The results concluded that silty soil led to faster plant growth, while loamy soil leads to faster germination. Therefore, this experiment does not support the initial hypothesis. This experiment does not support the hypothesis because although the seeds in loamy soil germinated first, the silty soil has a faster growth rate. Silty soil does better in colder temperatures and with frost than loamy soil. Figure 2 shows the process of the plant growth. In the beginning of the experiment, I can see that the seeds planted in loamy soil sprouted first, but later on in the experiment, the data shows the seeds planted in silty soil growing faster. Figure 1 shows the control variables in the experiment, such as weather conditions. It also shows when the seeds in silty soil began to outgrow the seeds in loamy soil. A limitation of this project is whether this experiment can be concluded for other winter-growing vegetables as well, or if this only applies to the arugula seeds used. A broader implication is that this experiment can be replicated with different vegetable seeds, and the results can be compared to conclude that a certain type of soil does indeed work better for seeds and their growth rate. Since there are more types of soil in the future, this project can be replicated with more types of soil that are generally used for growing winter vegetables. This will strengthen the conclusions drawn from this project and can be applied on a broader implication for others to understand which soil is best for their gardens. From this experiment, I concluded that different types of soil are essential for faster plant growth. Although both seeds germinated and had growth, if someone is looking for a specific type of soil that will result in faster plant growth, then there is a specific type of soil just for that. In this experiment, the type of soil for an increased growth rate is silty soil. This is for arugula seeds and has not been tested on other seeds. Therefore, this conclusion can only be drawn for the seeds specifically used in this experiment. This is from the beginning to the end of the project, and you can see that both seeds sprouted in the soil, but the silty soil resulted in larger plants in the same amount of time. Here are my references. Thank you for listening.